This is a STEM chat on probability and Punnett squares. So today's video is going to be on probability and how we use probability in genetics and how we utilize these tools known as Punnett squares. So before we get started today, I would recommend creating a table such as the one that I have up on the screen right now, where you are going to be taking some notes on probability as well as on Punnett squares. So again, if you need to pause this video in order to finish making this table, it should take up about a half a page in a standard size notebook. The essential questions we're looking at today are as follows. We're going to be looking at what is probability. We're going to be looking at how does probability relate to genetics, and how can we predict the traits of an offspring. So to get started with that, what is probability? So if we take a look at what probability is, it's going to be the likelihood that something is going to happen, or it's going to be a number that describes how likely it is that an event will occur. So for example, here, something that's impossible would have a probability of 0, and something that's certain where it's going to definitely happen would be a probability of 1. So for example, if you're flipping a coin, it's a 1 in 2 chance that you will flip a heads. Now, there is some science to say that maybe that's not entirely true, but again, we do have two sides to a coin, and one side is a head, one side is a tail. So it would be a 1 in 2 chance, or a probability of 0.5. Now, sometimes we use percentages when describing probability. So, for example, rolling a die, like a game die, it's a 1 in 6 chance that you roll a 2, or a 1 in 6 chance that you roll a 3, any of those numbers on the die. So if we take a look at the math for that, all right, we have a 1 in 6 chance, or a 1 out of 6 chance. So that would be simplified to a fraction of 1 over 6. Now, if you calculate the decimal by doing 1 divided by 6, you get 0.166 repeating. If you take that and you multiply it by 100, or a trick there is just to move the decimal point 2 places to the right, you would end up getting a percent of 16.67%. So you could say that it is a probability or a percent chance of rolling a 2 on a die of 16.67%. Now, how does probability relate to genetics? So let's recap here quick. Genetics is the scientific study of heredity. Heredity is the passing of traits from parent to offspring. So for example, Mr. Remillard has freckles, and both of his parents have freckles. However, Mr. Remillard is fairly tall, but both of his parents are both fairly short. So how is it that this happens? Well, we can thank Mr. Gregor Mendel, who started all of the experiments and the studies related to genetics and heredity, where he largely studied pea plants, and he took a look at a large variety of characteristics or traits of pea plants, and he said, well, what are the chances? So we're going to look back a little bit here at Gregor Mendel and combine it with something that Reginald Punnett came up with in order to start to figure out the probability of the passing down of traits from parent to offspring. So how can we predict the traits of an offspring? Well, we use these things called Punnett squares, which again were founded by Reginald Punnett. You might have seen that on our STEM fact on the first slide that we took a look at today. It's a chart that shows the possible ways alleles can combine in genetic crosses. So again, that word alleles, those alleles are going to be different variations of a certain trait. So if we take a look here, this is an example of a completely filled out Punnett square. Now, yes, it looks like bananas, but they are actually supposed to be pea pods. So you'll notice up top here, we have one pea pod where we have two alleles. Again, two alleles combined, we call that a genotype, and it codes for the phenotype. So here we have two recessive alleles in our genotype, which code for the phenotype of a yellow pea pod. Over on the left-hand side here, we have another genotype. However, we have one dominant allele and one recessive allele coming up with a heterozygous genotype, resulting in a green phenotype pea pod. So what we end up doing here, we'll go over how to fill these out. You might already be able to tell, but what we can take away from this is that we have 4 quadrants of our Punnett square. 1, 2, 3, 4. And that equals 100% chance. So it is a 100% chance that the offspring has some sort of trait. However, it's a 25% chance in one box, a 25% chance in another box, 25% in another, and 25% in another. Just like 4 quarters adding up to $1. So let's take a look at an example for this. All right, so when it comes to Punnett squares, okay, so if we have an example here, so one cat carries a heterozygous long-haired trait, which is capital S, lowercase s, and its mate carries a homozygous short-haired trait, two lowercase s's. Use the Punnett square. Can do this on scrap paper to determine the probability of one of their offspring having long hair and short hair. Now, I'm not a huge fan of cats, but this is a good example. So when we start off with any scientific word problem, I like to underline keywords and numbers, and then I like to circle what it is that we are trying to solve. So long-haired cat, capital S, lowercase s, heterozygous. Short-haired cat is the other parent, two lowercase s's, or homozygous recessive. And we are trying to solve the probability of one of their offspring having long hair, and what is the probability of their offspring having short hair. So what we like to start off with is we're going to fill out the genotype of one of the parents up on the top. So here I have a capital S and a lowercase s. That is going to be the long-haired cat. All right, so that's one of the mates. So we have the genotype of one up top and the genotype of the other on the side. So we have two lowercase s's over on the left. And now, in order to fill out this Punnett square, all we're going to do is we're going to move down one of those alleles from the first parent, and we're going to move over one of those alleles from the other parent. And that combines to give us a genotype of capital S, lowercase s in that top left box. Now, you might already see what we're going to do in that top right box. We are going to take down this small s from one parent, and we're going to bring over this small s from the other parent in order to result in a genotype of homozygous recessive. Down in this bottom, we're going to take this same capital S from the first parent and bring it all the way down here in this small s here. We're going to bring it on over to get a heterozygous genotype. And finally, in that last box, we're going to take this very small s from the top and this very small s from the left to combine into this bottom right box of lowercase s, lowercase s. So what does this end up looking like for our probabilities here? Well, a long-haired cat, or in this case, we only have genotypes that are heterozygous that would result in the long hair. That's a 50% chance because it's filling two of those boxes, 25 and 25, add those together, that equals 50. Where our short-haired cats, which in order to have a short-haired cat, you need to have a homozygous recessive genotype. That would be short-haired cats, or two lowercase s's. 25 plus 25, that is going to be equal to 50%. So we are resulting in a 50% chance of having a long-haired cat, a 50% chance of having a short-haired cat. Now it's going to be up to you to do some more practice today. Again, make sure that you spend lots of time looking at your notes. You can use your notes as much as you need to in order to fill out these practices, and always check the answer key and ask questions when you have them. This has been a STEM chat on probability and Punnett squares. Thanks for watching.